Today I'm going to talk about what we call AI innovation in the foundation model era. So I'm going to start by just explaining why we think this is so important. So really the promise of digital transformation for all of the companies that have gone through this process has been to get increased insights out of their data. But what a lot of companies have found is that the majority of those insights are actually trapped in their unstructured data. And unstructured data today, using traditional machine learning algorithms and methods, is extremely difficult to actually get value out of. And when you talk to companies, what they're realizing is by embracing these large language models and these foundation models, they can actually get a lot increased value, I should say, out of utilizing their unstructured data. And unstructured data is really, in our opinion, the most highly information-rich data. And it's also the most underutilized by most enterprises today because it is so difficult to get value out of. And one of the big promises of large language models is that it makes it much easier to extract and gather insights from this unstructured data. So if you look at the techniques that have been used for this over really the past 20 years or so, we're really entering into a new era of AI, as we like to think about it. There was 2000s, which were really dominated by traditional machine learning, which were great for task-oriented machine learning, where you had an input and an output. In the 2010s, we started to move into the deep learning era, which was really around neural networks and beginning to build these multi-layered deep learning, deep neural networks that you see really being deployed today in a lot of the forward-thinking algorithms. As you move into the 2020s, what we really see is there's this new era of AI, which is really brought about by foundation models. And I'll explain what that means to us in a second. If you look at what foundation models really bring, they bring on the left-hand side the ability to take all of your data, structured, unstructured, really any format of your data, take it into one of these foundation models, train that based on an extremely complex AI model that really has the ability to handle an immense scale that provides in-context learning. So the model learns from itself and actually gets smarter with the more data you feed into it. It can actually learn and connect the data to generate outputs from that. And the other thing that is really, I think, interesting about foundation models is it's also highly versatile. And what we mean by that is you reduce these 1,000 of traditional kind of machine learning tasks where it was input to output to a single model that can feed lots of different applications or lots of different tasks. And so this is, as we show here, kind of an example of what you can do with foundation models, which is you can take all these different sources of data that you have, you train it, you adapt it or fine tune it, and then you feed it into a number of different tasks downstream. Those tasks could be everything from translation to text generation or text summarization or search capabilities, all based off of the same model that's pulling from all of your data as an enterprise. Now, I'm going to build this out here. What are really the advantages of embracing these large language models and foundation models? First of all, just accuracy. The accuracy that has been able to be shown from these large language models is higher than you're getting on traditional machine learning or even deep learning models that you see today. As I mentioned, you can do lots of different tasks, so dozens of different tasks with one single model. there are these capabilities around generative capabilities. So the ability for the actual model to generate new language based on its context understanding. So you see things that are being used for this, like email generation, social media post generation, marketing materials that are being generated by these, question and answer generative capabilities. There's a number of these tasks that are being created and really completely new kind of AI-based workflows that are being generated out of these generative capabilities of the models. The other big thing is that because these models are so large and are able to generate understanding from themselves, you don't need a huge amount of labeled data for your initial training. That has also been one of the challenges of machine learning and deep learning eras, is that you had to have a tremendous amount of labeled data for the model to learn and to actually be accurate enough to actually produce quality outputs. What you're seeing with these large language models and really the foundation models is that they can learn with a very small amount of data, what's normally called a one-shot training or a few-shot training, and then actually generate these abilities to learn from itself as you put more data into the model. If you think about large language models versus traditional NLP, so think of the left-hand side really as these foundation models versus the right-hand side as traditional NLP machine learning sort of models like BERT. We've gone through a number of these, but probably the big things that stand out to me is a single model that drives multiple tasks and use cases versus thousands of separate models that you have to build, maintain, and update to be able to serve lots of different tasks. The second thing is these models understand language structure and context, and so they can be used to generate responses, generate text, which you really can't do in traditional NLP. Traditional NLP really processes language. It doesn't understand and generate language. And then I think the last one is really around doesn't require large data sets for these large labeled data sets for these initial trainings. What that really allows you to do is to get to value or insights much faster than having to go through the arduous process of creating a gigantic labeled data set to get the accuracy that you need. Now, why is this exciting to us and to people like you is that we really believe this is the $100 million business value opportunity. And the reason why is the types of problems that you can solve with these foundation models are huge, and they're really business changing. We like to use this quote quite a bit, which is from one of the leading researchers at IDC, who basically says that to stay competitive, organizations have to embrace and take advantage of these foundation models. This means investing in fully integrated stacks that deliver innovation at every layer of the stack, including hardware, model management, orchestration, and even pre-trained models. And really, what Matt Eastwood is really a thought leader in the AI and enterprise infrastructure space. It's really saying that look, enterprises have to think about how they embrace these foundation models into their business, or they're going to be left behind. Now, all that being said, there's a huge opportunity. We see a lot of market momentum on it, but this is hard. And there are three major challenges that we see today in deploying and building these foundation models. The first is the model sizes. So one thing that's been shown through lots of different research by both public and private companies and institutions is the model, the outputs or the insights, I should say, get better with the larger the model. And you're also able to generate more of these emergent generative capabilities with the larger and larger model. The complexity of that, though, is that the model keeps getting more and more complex. So if you go from just really, in late 2019, you had OpenAI bring out GPT-2, which was their really kind of first publicly released large language model with 1.5 billion parameters. A year later, they brought out a 175 billion parameter model with additional capabilities, more accuracy, and the ability to actually perform more tasks off of this. A year later, you now have 500, almost 600 billion parameter models that are really the state-of-the-art model today. And we don't think that's going to change because it's been pretty well proven that this becomes really an advantage for those that can deploy these very, very large models. Then the third thing that comes along with this is actually the training time to train one of these very large models. If you look at GPT-3 as a good example, there's been quite a bit of data out there that says even on hundreds of GPUs, it would take you months to train a GPT-3 model. And so the challenge there is not very many companies have the ability to do this, nor do they have the infrastructure to be able to do this or the actual skill sets. We've looked at this as SambaNova and said, look, if you try to do this on your own, this is really $100 million undertaking you're going to take as an enterprise. It's going to cost you people and process orchestration. It's going to cost you probably 3 years of development time in terms of data scientists, data engineers, deploying the infrastructure engineering. You're going to spend a lot of time developing the actual model and data sets to be able to train this to accuracy. And altogether, this whole process is probably going to cost you about $100 million in 3 years of time. Not very many companies have that ability to do that. We've recognized that and said, we think we have a better solution. Really, our solution is to take that time that would take you to go and build and train this model and actually provide to a customer an actual pre-trained large language foundation model that allows you to cut out all this development time and gives you a model that is ready to deploy and to get to those business insights that I talked about at the beginning. I won't go into this in too much detail. We have more details in our booth if you want to stop by and get more details. But really, what are we doing to make this enable this is really innovating at every stack, every layer of the stack. Like you heard Matt Eastwood from IDC talk about, is in order to really enable these foundation models, you have to innovate at every layer of the stack. Silicon, we build our own silicon, software, runtimes, compilers, systems, and then basically building and offering these pre-trained state-of-the-art models in a ready-to-deploy format. And we think this is really what the market needs in order to actually go and embrace large language models and foundation models at scale. The complexity of doing this on your own as an enterprise is just too high, and the skill sets to be able to do this are too sparse to do this at any sort of scale in the market. Now, I'm going to really finish here with one, I'll build this out, but one example of how some of our customers are actually using this technology to power applications or use cases today. This example is really around a call center or a contact center. And I won't walk through all the details here, but what you see here is at the top, you're walking through a customer task workflow. So customer calls with a billing issue, The representative issues and provides an answer. A rep makes a note in the CRM system, and then there's some sort of post-call survey. This is the basic workflow that a customer service agent would walk through. If you look at this and you take this in if you look at how you can apply a foundation model or a large language model to this, these are all tasks that could be automated via a large language model to dramatically decrease the amount of time an agent spends with an actual customer, and actually increases the value or the output as well. What you could see here is, when you've got the customer call, there's a combination of both unstructured and structured data that you're going to actually capture. You're going to want to capture the voice transcripts and then classify this using a natural language understanding. You're going to want to be able to search for actual data to provide the customer the right answer to their problem, but you're likely going to want to do this with more context around it than just a simple search engine. You're going to then want to probably summarize the call and the output. And then you're also going to want to do some sort of sentiment analysis to understand, was that a successful call or was that a negative call, and how do you root cause that? With each of these, what you can do is actually monetize, or I guess you can capture the improvement metric in each of these. You can reduce the call transfer time, you can reduce the call backs, and you can automate the generation of post-call summaries, all resulting in a pretty significant, what this is called is basically the amount of time an agent is dealing with a customer. You can see it's actually over a 30% decrease in the amount of time they have to actually interact with a customer. And you're actually getting better output out of that as well, because you're actually capturing then the customer sentiment and being able to understand, was that a positive or negative call? This is just a kind of simple example of the way that you could use these large language models and foundation models in a real world business application, like a contact center or a call center. So I'm going to pause there and say thank you very much. If you're looking for more information, you can visit us at the virtual booth. We will have people there to answer questions for you. And if there's anything else, you can also look at our website, SambaNovaSystems.com or SambaNovaSystems.ai, where you can find much more information about our products and our solutions.